Hi everyone, in this lecture let us discuss introduction to nodal analysis. During this presentation I am going to cover simple and principal node definition, how to select a node for a particular problem, what is nodal analysis, and a small introduction about this. Finally, I conclude steps involved to solve nodal analysis with a sample problem. Simple and principal nodes. Simple nodes are two or more branches meeting at a point. For example, let us see this circuit diagram. I can say this is one node where voltage source branch and resistance connected together. I can say this is another node where three resistive branches connected together. I can say this is also a node where one resistive branch and one voltage source meeting together. And finally, I can also call this point as a simple node point where three different branches meeting together. So these four nodes are called as simple nodes. But while solving nodal analysis, we are supposed to use principal nodes. These are the points where three or more branches are meeting at a point. I am taking the same example. Let us find out principal node. I cannot say this is a principal node since only two branches are meeting. I can say this is one of the principal node where three branches are meeting together. Once again, I can't say this is a principal node point since only two branches are meeting together. But I can say this is one of the principal node point. So on the same circuit I have only two principal nodes. Why should I choose principal node for the problem? In order to reduce complexity of the problem. Say for example, this node voltage is known to us, that is B1, and similarly node 3 voltage is B2. So these are the node voltages readily available in the problem, so we do not want to choose those things. Rather, we don't know the value of node 2 on this diagram, whereas in the second one node 1. So it is enough to choose three or more branches at a time while solving nodal analysis. How to select a node in a given problem? It's very important. We have to choose appropriate node such that you can easily solve the problem. There are simple guidelines here. One is three or more branches meeting together. As I said earlier in the previous slide, there must be a branch between two nodes. This is another important criteria to choose a node. Say for example, I am choosing nodes of the given circuit. Remember, I am going to select only principal node for solving nodal analysis. I can't say this is principal node since two branches are meeting together. I can say this is one principal node point where three branches are meeting together. Similarly here 7 ohm, 2 amps, 7 volt as well as 3 kilo ohm meeting together. I can say this is another principal node point, and all these points are common and I can choose one node. You can also ask me, why can't I choose this as a node point? Yes, you can choose this as a node point. If you are choosing this as a node point, say for example 4, now check node 2 and 4. There is no element is present or branch is present between 2 and 4. So as per my second guideline, there must be a branch between two nodes. If you are choosing second node as well as fourth node, there must be a branch, but here it is not. So this is not correct way of choosing the node, right? Why can't I have one more node at the bottom? Can I say this is another node? Once again the same thing. If you consider this is node number 5, there must be a branch between two different nodes. Say for example 1 and 5 we have a branch. So 1 can be a node, 5 can be a node. But look at 3 and 5. There must be a branch, but it is not. Hence either 3 or 5 can be a node. So that I have eliminated, only I have chosen. This is correct way of identifying the node. You just stick to these two rules, you can easily find out nodes in a given problem. So how to choose branch current direction? Branch current direction is very important while solving nodal analysis using KCL method. Once again, there are few constraints here. Choose any direction. There is no restriction, you can choose any direction. But once the direction is chosen with respect to one particular node, do not alter branch current direction with respect to other nodes. These are the two guidelines available. Once again, I am taking the same problem. Now, how to choose branch current? Randomly you can choose. Say for example, I am choosing this as I1. So this is I2 and this is I3. With respect to node number 1, I have 3 branches. One branch having the current of I1, second branch having the current of I2, third branch having the current of I3. Now come to node number 2. Node number 2, I have 1, 2, 3, 4 branches. One of the branch current is already fixed, that is 7 kilo ohm branch current is fixed with respect to node number 1. So stick to this rule, don't change this direction when you fix a branch current for this particular node branches. So 2 amps current source itself, direction is given, no need to bother about this. This is I4. Let's fix the current direction here. This is I5. All the branches have the current direction. This is how to choose branch current direction for nodal analysis. Stick to these two rules in order to find out better branch current direction. Then nodal analysis. What is nodal analysis? It is one of the generalized procedure to find out node voltages, thereby response on any point of the circuit. What are the features of nodal analysis? Nodal analysis is based on the application of KCL. If you have n number of nodes, there will be n minus 1 number of equations to be solved. Solving n minus 1 equation, all the node voltages can be obtained, thereby any response on the circuit is concluded. What are the steps involved in nodal analysis? Suppose nodal analysis using KCL equation, then step number 1 is identify principal node and choose one of them as a reference node. Step 2, label the node voltages with respect to ground from all the principal node and mark the branch current directions. Step 3, write the nodal equation at all principal nodes except reference node. These nodal equations is obtained by applying KCL. Step number 4, solve the nodal equations that we obtained in the previous step and find out node voltages. These node voltages are helpful in finding response on any point of the network. Let me go to the sample problem. Calculate current in 2 ohm resistor using nodal analysis of the following circuit. I am going to solve this problem using two different methods. Method number 1 is KCL equation. Now this is a circuit I am going to solve it now. I will follow the step-by-step procedure. Step number 1, identify principal node. I can't select this point as principal node point since only 2 branches are meeting here. I can say this is one of the principal node. I'll mark it as 1. This is also not a principal node since only 2 branches are meeting here. This can be a principal node. This is reference node. V2 is assumed to be 0. Mark branch current direction. So I will take this as I1, this as I2, and this as I3. According to KCL, current flow towards a node is equal to current away from the node. So at node 1 by KCL I am writing this equation: I1 alone towards a node, that is equal to I2 plus I3. These two are away from the node. Then what is I1? In order to write down I1 equation, this is your I1 direction, which is connecting node number 2 to node number 1. If you move along this direction, this current leading positive of the voltage source, so take plus 10 minus voltage at this particular point. Voltage at this node is V1. Then on this path, what is the resistance available? 5 ohm. That 5 ohm is denominator. Similarly, I2, how to find out I2? I2 is flowing between node number 1 to 2 in this way. What is the potential of this particular point? V1. What is the potential of this particular point? V2. V1 minus V2 divided by 2. V1 minus V2. V2 is actually 0. We have assumed. So divided by 2. Coming to third one. This is how current flow direction is assumed. Now it is flowing between 1 and 2 once again, but this way. So from which node current starts to flow? V1. So go for V1. Okay. So it is moving towards V2. Already V2 is 0. I have one voltage source here. Current leaving negative of this voltage source. So minus 5. Divided by what is the resistance available on this path? 1. So this way we have to write down current in terms of node voltages. And simplify this, we will be finding this equation. Solve this equation for V1. You may get V1 as 4.12 volt. Once you find the node voltages, in fact on this problem I have only 2 node voltages, namely V1 and V2. Among this, V2 is already assumed to be 0, so it is enough to calculate V1, that is 4.12 volt. Now calculate current in 2 ohm resistor. 2 ohm resistor is here. What is the current flow in 2 ohm resistor? I2. Find out I2 equation. Already we have written here V1 minus 0 divided by 2. So substitute V1 value here. We'll be finding 2.06 amps current in 2 ohm resistor. So this is method number 1. Then another method called matrix inspection method. Here slightly the procedure is different. Step number 1, convert all voltage sources into current source. This is to be done if the voltage source is present. Otherwise, you can identify the principal node and choose one of them as a reference node. Treat that node as ground. Step 2, as usual, label the node voltages with respect to ground from all the principal node. Formulate network equation. I with the dimension of n minus 1 cross 1, that is current vector. Inverse resistance matrix n minus 1 cross n minus 1. V voltage vector with the dimension of n minus 1 cross 1, where n is number of principal nodes. Then solve the network equation obtained in step number 3 to calculate node voltages. Let me take the same problem and try to provide the solution using inspection method. This is the actual problem I have solved in the previous slide. Now consider this problem using inspection method. The primary step is to identify is there any voltage source. Of course, I have two voltage sources. I want to convert these two voltage sources into current sources. So converting this portion into a current source, you may get current source in parallel with resistor. This current source with the direction of upward arrow mark, because top one is positive here, this current value is I, which is V by R. V is 10, 10 by 5 is 2 amps. What about resistance value? Blindly you take 5 ohms. Then draw the 2 ohm resistor as it is near circuit. On this portion I have 1 ohm with 5 volt. This has to be replaced by current source. Resistance value blindly 1 ohm. You take current source as 5 by 1, 5 amps. Arrow mark direction upward because upward plate is positive. Then the next step is to identify node. You consider this top portion, all this considered to be connected in a common point here. So I can consider this is node number 1. Similarly at the bottom, all the points are considered to be a common point. Let me assume that this is common point. Let me say V2 is a reference node and voltage at this node is 0. So as usual, I have to find out node 1 voltage, thereby I can conclude current flow in 2 ohm branch. Now formulate network equation. Here I have 2 principal node, but n minus 1 I have to consider for the equation. That means only one equation will come. Now look at the equation. I is equal to 1 by R into V1, where V1 alone we have to find out here. So what is a current? Here I have two current sources, both moving towards node number 1. So I have 2 plus 5. Then on this node number 1, I have 3 resistors connected. So go for inverse of each case. 1 by 5, 1 by 2, 1 by 1. Inverse of this resistance. Then V1 is an unknown voltage we have to find out. Then simplify this, we'll be finding 7 equal to 1.7 times of V1. Then V1 is 4.12 volt as we have seen in the previous method. And finally, current in 2 ohm resistor is I2. Here this is I2, which is V1 by 2 or V1 minus 0 by 2, where V1 is 4.12 divided by 2 becomes 2.06 amps. So this way we have to conclude solution using inspection method. I hope you understand nodal analysis with a simple illustration. For more update, subscribe my channel.